we're going to look at linear regression. Linear regression using a grapher, or like a TI-84 is a good utility mechanism to use for this, based on a table of data. Here we have times of when a temperature was recorded in degrees Fahrenheit. This looks like it might be wintertime somewhere, at least in a much colder climate than southern Florida here. And we can enter this into our calculator and it will tell us, we can discover how we can program it, or at least use its functions to tell us what a line of best fit might be to predict other temperatures. Let me look at more of the graphing utility here. We first want to enter the data in. Now we're going to use our stat button, and we're going to edit our stat list. We're going to select that, and our list 1 is just going to be our times. We're going to have 10 o'clock, 11 o'clock, 12 o'clock. Now if we go to 1 o'clock, it's going to give us some skewed data because the 1 is going to be prior to the 10 and the 2 is going to be prior to the 10 as well. So let's make this 1300 and 1400, our 24-hour clock, so that our times are in sequence. This will similarly be 2000 hours. So we'll do 13 and 14. Our second list is going to be our temperatures, 17, 19, 21, 23, 24. Once we have this data, we can go ahead and graph this. We're probably going to get an error, or at least not going to see very much, because we need to go to our stat plot. Second y equals is our stat plot. We want to make sure that it is on. Right now it is off. So we're going to move over. We're going to select this, make sure that it is on, and then we can go back to our graph. We're still not going to see it because we're looking at 10, 11, 12, and 17, 19, 21. It's off of the graph. So we're going to zoom, and if we scroll down, the 9th option is zoom stat. So we're going to zoom on the statistics that it's graphing. Hit enter on that, and we see these data points on this scatter plot graph that we've just created. Now, that's well and good. Let's look to see what the line of best fit might be. Let's go back to our main screen. We're going to use the catalog button, which is second 0. Right here, it's catalog in blue. So second 0 is the catalog, and we can scroll up and down. We want to find the linear regression. Let me write that down. The linear regression in the form ax+b. Now we can scroll all the way through here, or we can use the alpha lock is already on. We have the A in the corner. That's our alpha lock. We can go ahead and press the L button, which is the right parenthesis, and it skips down to the L. So we can scroll down through here, and we have all these L's. We want our linear regression ax+b. The reason we want this is because this is in slope-intercept form. A is the slope, B is the y-intercept, ax+b, or mx+b if you prefer. So it already has list 1 and list 2 saved in, so we just enter again, and it tells us what the A and the B are. So this gives us y equals 1.8x minus 0.8 as our line of best fit. We can put that in to the graph, hit y equals, and we'll do y equals 1.8x minus 0.8, and we'll graph this. And as expected, it doesn't hit all of the points. We wouldn't expect it to, but is a linear equation, a straight line, that is going to be a line of best fit for all of those points. If we want to predict the time at 8 o'clock in the afternoon, we can go back to our main screen by second mode, where that's our quit, and we can plug 8 o'clock into our linear equation, which is going to be 1.8 times 20 hours minus, not negative, minus 0.8, and that's predicting that it's going to be 35.2 degrees at 8 p.m. Now, not likely. If 10 a.m. is 17 degrees, we're probably not going to hit 35 degrees at 8 o'clock when the sun is already set. The sun, in this situation, the sun is likely to probably set around 5 o'clock or so, more northern latitude, and we're not likely to have a 35 degrees. So, and likewise, at midnight, it's going to be even higher. At 4 o'clock the next morning, it's going to be even higher. The linear regression, the linear model for this particular situation doesn't really work, but it may work for times in between 10 and 2 o'clock to get an estimate of what those temperatures might be during the morning hours or maybe the early afternoon, because it's probably peaking around 2 or 3 o'clock, that high temperature, oftentimes between 1 and 3 o'clock. Let's look at another example. Population. Let's go ahead and clear our data. We want to enter our data in, and likewise, since we don't necessarily need to have 1970, we can use 70, 80, 90, 100, 110, and so on. But we'll go ahead and punch in the entire number, because when we use statplot, it's going to adjust it for us anyway. Let me go ahead and clear out what we need to use. So we're going to edit our list, and we can just type over this. 1970, again, stat and edit is how we get to our list 1 and list 2. 1970, 1980, let's try that again, 1970, 1980, 1990, 2000, and this might be census data that we're using. 13,100, 14,010, 14,910, 16,200, 17,800. Disclaimer, I made this data up. It's not a real city, but it potentially could be. Let's look to see what happens here. Let's go to the graph and see what happens. It's not showing us anything, probably because we are using the same parameters, the window, as our earlier problem. So all we have to do is change the zoom to our current setting, zoom stat. And voila, we have a nice scatter plot of what looks like we might be able to get a linear regression. Again, we're doing a linear regression, so let's go back to our main screen. We'll do our catalog, and then we're going to choose L, and scroll down or arrow down until we get linear regression ax+b. We're going to select that by hitting the enter button. Hit enter again, and it gives us our y equals 115.9x minus, well, this seems like a very large negative population, 215,437, which suggests that at year 0, 2 millennia ago, the population of this particular city was negative 215,000 people. Not likely. However, we're looking at this 50-year span or 40-year span of population data, not 2,000 years. Of course, that could never happen. But let's graph this. Let's go back to y equals 115.9 x minus 215,437 people, and we'll graph that. Lo and behold, for the window that we're looking at from 1970 to 2010, that linear equation models it fairly closely. But what about 2050? If this is a f of x equals, we want to know, well, what about 2050? What does that equal? Well, we're going to plug in 2050 and see what we might come up with. So this is 115.9 times 2050 minus our large negative population, and we'll have an estimate of 22,158. Now, this is a plausible number. We see that it continues to increase, and it would likely increase in the future.